the goal of it is to show you what we think is the state of the art in facial recognition today, and how you can adapt algorithms to work with pretty much any infrastructure that exists. And I think that's really where our company comes from. Our approach is that we're agnostic to the infrastructure. A lot of people have things already deployed, and they want to be able to add facial recognition on top of that. Or they want to be able to use diverse cameras and not be in one specific vendor ecosystem, right? That's kind of the different aspects there. So we take a very different approach to facial recognition. Nuvoola is basically a cloud services and AI innovation company. A lot of OEM vendors add AI portfolios into their infrastructure, having complete control of the cameras and the pre-processing and so on. We're taking the opposite approach. We're taking AI as our core strength, and then we're adapting it to different scenarios. But basically, just to summarize where facial recognition is today, we're seeing that it's starting to become widely adopted and used. But the other thing we're seeing is that in practice, there is a large variability between what can be done in a lab and what's actually feasible in a real-world environment. And that's just simply because the context, the lighting, the distance of subjects and things change. So in terms of the ability to reduce false positives or false negatives in a controlled lab environment, you can get fairly good results, but in the real world, you can see very high variation. And we've seen studies that came out from actual law enforcement agencies that show that their false positive rates are close to 100%. But so basically, why would you use that kind of system? And it really is dependent on the scenario and the use case as well. So I have to say, it's these broad figures can be radically changed by tuning, by optimizing, and knowing a specific use case. But why would law enforcement in the City of London want to go through 100 pictures to find 2 that are actually criminals? It's because it's much better than the alternative of not identifying these people at all, right? So having human intervention, narrowing down the subjects to look at and review is still helpful to them. But if you want to get to an AI perspective where you want to actually reduce the human involvement dramatically because you don't have the money to do that, like a law enforcement agency might in a terrorist environment, then the idea is to try to increase your accuracy dramatically so that the humans are only consulted in exceptions, right? And that's what I wanted to talk about today, and how technology now can be adapted to that. Just to summarize, if you're looking at the weaknesses of a closed ecosystem using a single AI model, typically the way AI works is it feeds on samples, right? The more you can feed in terms of samples, and then the more you can train it that this is right or wrong, the more the success will improve over time. So the accuracy depends on food, essentially lots of images, lots of input saying that this is right or wrong. And typically what would happen in a private environment is you'd get a collection of images, say 5,000, if you're lucky, maybe 10,000 a day for a certain enterprise or facility. And from that, you have to have somebody look at all the positive matches and negative matches and determine whether or not they actually are true or not. Then you go back and you train the model to be better next time, right? So this is the kind of input that's required for an AI model to converge very quickly on proper facial detection. When I say here learning is expensive, it really means that if you're actually getting individuals and peoples to review pictures, then you end up in a situation where there's a limit to how much you can afford to analyze, so you end up sampling, and your accuracy is always limited to a certain amount. So you can actually overcome this quite easily. The major shift here is to employ cloud-based AI solutions to do facial recognition. So if you're a partner of Microsoft, for example, or Amazon, you can use their API and you can go and directly access their facial recognition software. And if you look at Google, they're probably processing several million facial recognition images a day. And then there's people like you and me who sit there and say, yeah, that's my dog, that's my wife, that's Jacob, my son. And over time, of course, all this labeling is actually training the Google models to do better, and also the data scientists that they have will start to refine the models because they've got so much data to work with that they have a much better opportunity to train, right? And so in this case, basically the conclusion is we're never going to be able to replicate the success of the hyperscale providers on our own with a single, open source facial recognition algorithm, because they have 3 orders of magnitude more data than we'll ever have. And there's another reason why you might want to trust them to do your recognition for you. So I took a statistic here from AWS a year and a half ago. They had 1,178 openings in their company for facial detection data scientists, which is basically more people than most security vendors even have in their entire company. But on top of that, they were spending $230 million to recruit people just for that, and that's a year ago. So currently, there's over 11,000 data scientists at AWS that are actually working on AI of one form or another. And so the question comes down to, at some point, do we beat them or do we join them? And do we take their technology and use that to help us really recognize things at a much higher level of accuracy? The other thing that we've noticed, because we work with Amazon and Google and Microsoft on a regular basis, is that their models are always changing. So not only are they making the best algorithms, but they're actually updating them at the speed that they update your Gmail, your Google Maps. New features are appearing, new accuracies. So one day you might see AWS returning image scores at 60%. The next week it can go up to 92% because they've found some new way to detect better. And this makes it very interesting because there's no one model that you can trust as being exclusively the best one to use, right? Because they're always changing, because they're always evolving. So this brings you to another conclusion. If you say, well, okay, I have open source facial detection, I've tuned it with my data scientist, my team of 20 people has done the best they can, but I know that Amazon or Microsoft has significantly more powerful algorithms. Which one will I choose, right? If I want to use that to do facial recognition in my situation, it's hard to choose because they're actually changing over time, and one that was the best today might not be the best tomorrow. In that case, there's a simple solution, is that because their price is very low to consult them, you might as well have a second consultation, right? So if you go to a doctor and the doctor says, you need a heart transplant, you might actually say, I'm going to go look for a second opinion on that or a third opinion. And if you're looking at increasing the security of people entering a very important facility or trying to determine if, let's say, a VIP is entering a stadium so you can make sure you roll out the red carpet, it might make sense to have a second opinion, especially if you're talking about false positives in the 90% range. That's really like going to give you a lot of problems in the case of trying to identify individuals for theft or for loyalty. So the idea here is very simple, and you would take multiple models and combine them together. So you send the same image to, let's say, 2 or 3 different facial recognition models, and you use a technique called fusing to bring those scores together in an automated way. And why does that work? So what I'm taking here is statistics from, we were at the GSX show in Las Vegas, and we took 12,000 images of people using video that came to our booth during the 3 days we were there. Here's an example of one individual who came back to the booth a number of times. And you can see that from the position and so on, there's always a different kind of context or angle to the person's face. These are the 3 providers we use. We had the gray bar here is facial recognition running open source locally on a GPU. So it's a completely self-contained local unit. And then we used Microsoft Azure and AWS facial recognition on the cloud. And we ran that on every image. So we ran all 3 each time. And then we reported here the scores of the recognition score that came back from each of those. So basically you send an image to AWS, it comes back and says, I'm 60% sure that's the person that was here before. And what you can see is very interesting is that if you just take the best result, which came from AWS, there are times where it comes back with a 0 result. It says, I don't recognize this person at all. Potentially it's the position that they're in, and we've seen that with AWS. A lot of the time, I'll show you a real world example in a minute, when the person's off axis and they're seeing one eye, it doesn't work as well. Microsoft has a very strong ability to work on off-angle sides. So if somebody has one eye or there's a clip in the picture or somebody's in front of them, it works very well. And the open source facial recognition, it never really gets above 50% score and confidence level. But what's the most interesting of all this is what we learned over time, they almost never fail at the same time. So if you look at when AWS is not producing a result, the other 2 models are giving a result. And the same thing is true here when Microsoft was unable to detect this because the angle was wrong. The other 2 are detecting a result. So what you find is usually 2 out of the 3 will come back with something that's positive and a credible score. So that leads you to believe that you could combine these together in a way that would allow you to basically get a weighted result that would tell you, like, if these 2 are accurate and they're above a certain percent, you can imagine algorithms for this. You can probably make up your own, right? You say, well, if 2 out of 3 are above 50%, I'll say that's a person. Now, you have to train over time, and you have to decide what those thresholds will be, and that's really where you get into the details of tuning these models to work. But that's essentially the main part. The second part that's interesting on the right-hand side, you'll see that if I trend it out to like 100 samples, they all improve. So all the models will get better and better over time because in the gap between this sample and 100, we're retraining the models with the data we already have. But unlike a closed system where I have to rely on a person to say, yeah, that guy's the same as that guy for sure, what we're doing in this case is we're using the models to train each other. So if I know that Amazon and Microsoft are saying very high likeliness that this person is who I expect it to be, but the open source model is returning a 0, I can take that image and send it to the open source system and say, it's a known good person, retrain yourself. So we can actually use the models to retrain each other. Whichever ones have a very high level of confidence can be used as a new image to retrain the data set and say, this is a good image. Next time when you see something like that, it'll get a higher result. So over time, after just about 100 samples, you get to the point where all of your models are getting closer to, let's say, 80+% accuracy. And this required no human intervention. So it's scalable in this kind of environment, right? So how does this basically work in practice, right? You're taking the single image and then you're moving it from the camera and you're going to send it to multiple models. And then you have to decide how am I going to combine this so that I can actually create a sensible score from that. Well, the problems start to happen when you try to imagine how that will happen, right? One of them is we've talked about each model from the cloud is changing over time. So they're improving. You can't have a static model where you say, I'm going to take 50% of my results and then add that to 25% of this, make a weighted average, because these things are changing depending on the context. So you can't come up with a simple formula that's always going to work for these models to give you the best result. So the conclusion is that you have to adapt your scoring of the AI models to, as time goes by, and with the acknowledgement that the models that are being used are AI-based and they're going to change. So the conclusion that came to our team as an AI company is we said, well, the only way to work with something that's always adapting is to actually use AI itself to try to figure out over time which one is the best result. So what our engine will do is absorb the data from all of these, then look at the context, look at the lighting, look at the angle, the different 128 points that you're tracking on each face, and say, well, in the past, Microsoft has done a very good job of this, but something's changed recently, and AWS is coming out with higher confidence scores. I'm going to shift this around, and at some point, it learns it's on its own. So it's a deep neural network learning how to analyze the input from other AI engines, which is kind of a fusion approach that then again doesn't rely on us to become more accurate. It does it by itself. Here, I'll explain how you would do this in practice. Because if I took a video frame and I took out 30 frames and I sent all that to the cloud every second, it would be prohibitive on your internet access. It wouldn't make a lot of sense, right? So what you do in that case is we use an edge device. So what we normally do, an edge device meaning a few $100s, something with a GPU on it, like a little module the size of a deck of cards, and that will do half of the work for you. So it's going to pre-screen. And what the role of the edge device is, it connects to multiple different cameras. Its role is to actually look at the images and pre-process them, right? Adjust for lighting and compensation for things like that. And it's going to do, the first part of facial recognition is just detecting the face, right? So the two components that you need to do is detect the face, then you're going to recognize it later. But first you have to find the face in the scene, right? Which we see on our phone. It's very good at picking up faces. So the edge device has an algorithm that runs on the GPU directly and actually allows you to identify faces of a certain size at a certain distance, all this kind of stuff. And then selects, so it says, okay, this is your face, this is a face. From there, I'm going to look at this sample set on the video. I'm going to pick out the best frame. So maybe you pick out 3, right, frames in let's say a second. And then, so now you've got to the point where you have a very condensed set of data. Each one of these frames are talking about 300 kilobit. It's not like a multi-meg 4K image or something. And then those are sent to the cloud. So basically, it allows you to scale very rapidly. We have some customers, they have remote locations, and the only way they can connect is through like a LTE modem or a 3G modem. So it has to be extremely edge efficient, and you would put an edge device wherever you have, let's say, 10 cameras, so at different locations, corners of a building, and they can absorb that and then upload to the cloud. So the face detection is happening at the edge, and that helps you reduce dramatically the upload. And then what's happening, once it gets to the cloud, you're using multiple models, facial recognition, to recognize the faces, and then you're going to use the scores that come back from them and fuse them together. And then you're going to use the learning capability on top of that. So this is actually extremely scalable, especially because once you get to the cloud, this is scalable basically limitlessly to whatever scale you want to go, even in a multinational environment. Does that answer the question? Make sense? We can show you how that works. So this model here, we do have this running live at the show, so it's kind of fun to see it working if you want to come and see it. We have a partnership with NVIDIA. We not only use them for edge devices, we can use Intel devices as well, but we also have a partnership with them. They actually host their own cloud, so NVIDIA has a AI cloud. So if you really want to use like serious GPU resources to do some data science, you can actually, as a partner, just access that anytime you want and do some experiments on it. So that's how we optimize our edge. So we're not a hardware vendor either. We basically specify what to make and what to install. So here's an example of an app we have that gets the results back to, let's say, a security guard or somebody who's responsible for security. And this is a feed that came from the last show at DC, last one, I guess, GSX. And George is our data scientist, and he's back here today. So what is happening here? Basically, he came along and he wasn't indexed before. So he wasn't enrolled into the system as a known employee. So he's getting a yellow scan. The facial recognition open source software, this is why I'm a little skeptical of limitations of open source. It's recognizing him with a 41% score, even though he was never enrolled. So it basically it's saying it thinks he's somebody else, right, that we've seen before. Amazon and Microsoft are coming back with a 0 score, and our Nuvoola index, which fuses them together, is saying we're confident this is a 0 based on the situation. Now, in the case of another colleague of mine, you can see this sort of angled view. So it's not a great shot from the video. That's the best one that came from this situation. It's kind of clipping off his ear and stuff. So Microsoft's coming back with a fairly high score, and so is our open source system that's running on the edge device. Amazon's saying, I don't recognize this, but we know this is AJOY because I work with them every day. So it comes back with a confidence score here. Now, over time, if you actually, the system trains, end up with a different sample, right? So here we've gone through only 3 different samples. It's already coming out with a much different type of result. And this is what you want your system to do, is over time, quickly learn it within 100 samples exactly who the person is. And you can see the fuse score together going up higher now, right? So we've been able to train AWS here. And we believe 2 over 60 makes sense. So they're actually teaching AWS. That was AJOY, and now it's getting a higher accuracy rate. So overall, if we just take that one user, of course, if you're using this at our booth and AJOY works at our booth, he's been scanned more than anybody else. He's getting picked off, and it's like a paparazzi for him. And you can see the statistics over time. So this is the kind of thing you would be able to use to help determine which images need to go for manual processing if you're just at the beginning of the training phase. You can see that on average he's getting a very high recognition. AWS is coming out significantly higher in terms of its scoring. But the classification, the classifier actually also has to take into account, how often is AWS wrong when they say they're 95% confident. So there's another level there of AI that has to kick in. And you sort of see the log file now of he was successfully enrolled by the company as an employee. He's a known person, and these are all the different scans that happen in different times. So yeah, it is really real time. The latency between the time he walks in front of the camera till you have a score, it's sub-second. It's usually around 300 milliseconds from the perspective of the cloud. And then you have other statistics. So now what I'm showing you here is basically the log of different locations, different branch offices that we have, and the different times of them all, and how the system scales up to do recognition across them. And the conclusion of that is really it is a real-time system, and it's self-optimizing, and you can see over time how the accuracy changes yourself. So you can actually look at those statistics. And that's really what I wanted to show you guys today is the general concept, right? This is something that actually a lot of companies can go out and apply. And it's just sharing a best practice that we've seen of one of the different areas that the company touches in our day-to-day.